Hello good people, I would like to talk about keto-enol tautomerism under basic conditions. So it is a conversion of a keto form into an enol form and back again. A keto form is any aldehyde or a ketone that also has an alpha hydrogen. What do I mean by that? Well, this carbon here with the yellow dot, that is the carbonyl carbon. The one next to it is an alpha carbon. Any hydrogen attached to it is referred to as an alpha hydrogen. So generally speaking, as we go from a keto form to an enol form, the alpha hydrogen will end up over here attached to the oxygen. The bonds that were between the alpha hydrogen and the alpha carbon, pardon me, not the bonds, the bond or the electrons of the bond that were between the alpha hydrogen and the alpha carbon will end up as the pi bond between the two carbons. And the pi bond between the carbonyl carbon and the oxygen will end up as a bond between oxygen and hydrogen. All right, let's look at a more specific example. So here's my starting material. I have chosen a ketone this time, 2-butanone. And let me number the carbons. 1, 2, 3, 4. And this is my carbonyl carbon, which makes this carbon the alpha carbon, but also this carbon the alpha carbon. All right, I said this happens under basic conditions. So a base comes in and the electrons, the lone pair electrons of my base will be attracted to one of the alpha hydrogens. As that happens, the bonds, not the bonds, the electrons that were the bond between the alpha carbon and the alpha hydrogen will end up on the alpha carbon. And so I will end up with a carbanion and a water molecule. So this carbanion, the carbon that carries the negative charge, has a lone pair of electrons on it. I'm going to number the carbons again. So carbon number 3 has a lone pair of electrons on it. What is the next step? Remember, we are trying to get to an enol form. So that means we need to get a double bond and we need to get an alcohol functionality. So the lone pair electrons on carbon number 3, let's do that in the right color, they will end up forming a pi bond between carbon 3 and carbon 2. The lone pairs of the electrons on the carbonyl will be attracted to the hydrogen on the water molecule, and the electrons of a pi bond between carbon and oxygen will move up onto the oxygen. As a result, we'll end up with a double bond between carbon 3 and 2 and alcohol functionality on carbon 2, and we have also recovered our base. So how do we go back? How do we go from our enol form back to a keto form? Well, we need to recover the carbanion again. So how do we do that? Well, the pi electrons between carbon 2 and 3 will end up back on carbon 3. The lone pair electrons on the oxygen will end up between carbon number 2 and the oxygen to form a pi bond, and at the same time the lone pairs of our base will grab the proton on the alcohol, and the electrons that make up the bond between the oxygen and the hydrogen of the alcohol will end up on the oxygen. So we'll get a carbanion back and we'll get water back. What is the final step? Remember, we are trying to get back to our ketone. So the final step will be that these lone pair electrons on our carbanion will be attracted to a proton on our base. And the electrons that were between the hydrogen and the oxygen on our base will end up on the oxygen. And so we are back at our ketone, and we have also recovered our base again. That is all for now, and I will see you on the flip side.